In a field outside Mexico City, archaeologists found two pits, each barely deeper than a backyard pool, packed edge to edge with the bones of 14 mammoths. Someone dug those pits on purpose. Someone chased 14 mammoths into a hole, on foot, with sharpened sticks and rocks, roughly 15,000 years ago. That's not luck. That's an ambush engineered to work every time. So here's the real question. If a handful of humans could bring down the largest land animals that ever lived, what did we actually do with that power? And did it cost more than we ever admitted? The idea has a name. In the 1960s, geoscientist Paul S. Martin at the University of Arizona noticed something strange while mapping when giant animals vanished around the world. Woolly mammoths, giant ground sloths, saber-toothed cats, nearly all of them disappeared not on some slow geological clock, but within a couple thousand years of humans showing up on that continent. Every single time. Martin called it the overkill hypothesis. Humans arrive, hunt the biggest, slowest breeding animals faster than they can reproduce, and an entire ecosystem collapses in what is, geologically speaking, the blink of an eye. And slowest breeding matters more than it sounds. A mammoth carried a calf for close to 2 years, and then usually waited several more before having another. A deer can replace itself in a single season. Once hunting pressure outpaces a birth rate that slow, there's no recovering. The math only runs one direction. Martin didn't build that idea on guesswork. Across the American Southwest, archaeologists kept finding the same scene: mammoth skeletons with stone spear points lodged directly between their ribs. At the Laner Ranch site in Arizona, researchers uncovered the remains of at least 9 mammoths alongside Clovis points, stone tools so distinctive they gave an entire prehistoric culture its name. These weren't animals that wandered into a bog and died of natural causes. Someone stood close enough to drive a spear into bone. And the pattern keeps repeating well beyond North America. In New Zealand, all 9 species of moa, some standing 12 feet tall, vanished within roughly 100 years of Polynesian settlers arriving around 1280 CE. In southern Chile, at a site called Monteverde, archaeologist Tom Dillahay found stone tools mixed with the butchered remains of a giant ground sloth, evidence that people were eating an animal the size of a small elephant nearly 15,000 years ago. Ireland's giant elk, antlers spanning 12 feet tip to tip, disappears from the fossil record right as human hunting pressure intensifies across Europe. Australia might be the strangest case of all. Long before mammoths, before moa, before Monteverde, the continent was home to Diprotodon, a wombat relative roughly the size of a small car, along with kangaroos taller than most adult humans. Ecologist Christopher Johnson at the University of Tasmania has spent years tracing the timeline, and it lines up the same way it does everywhere else. Humans arrive on the continent somewhere around 50,000 years ago. Within a few thousand years, nearly every animal over 100 pounds is gone. Australia never went through the dramatic ice sheet swings that hit Europe and North America, which makes the climate excuse harder to lean on there. Something else was doing the work, and the timing keeps pointing at footprints instead of weather. But hold on, not everyone agrees humans get all the credit, or the blame. British paleoecologist Anthony J. Stewart spent decades arguing the timing is messier than Martin made it look. Some megafauna died out well before humans arrived in certain regions. Others hung on for thousands of years after. Stewart's research points to the same window that produced dramatic climate swings, the end of the last ice age. Entire habitats flipping from tundra to forest in a few centuries. Grasslands that mammoths depended on, simply shrinking out from under them. Maybe it wasn't a single killer. Maybe it was 2 forces hitting an already stressed population at once. That's where taphonomy comes in, a term for the study of how bones get from a living animal to something dug out of the ground thousands of years later, and everything that leaves a mark along the way. A cut on a rib, a scorch line on a bone, the exact angle a stone point punched through a shoulder blade. Taphonomy is basically forensic science for extinction, and it's the only tool researchers have for telling the difference between a human killed this And this animal just happened to die near a river that later became a fossil bed. Gary Haynes, a taphonomist at the University of Nevada, Reno, has spent years studying exactly that on mammoth kill sites, and his work adds a genuinely unsettling wrinkle. Some of these sites don't look like a single hunt. They look reused. The same location visited generation after generation. Hunters returning to a spot that had worked before and just kept working. Which brings us back to that field outside Mexico City. Researchers still aren't certain whether the Tultepec pits were dug once and got lucky 14 times, or whether they were a known, trusted trap that families kept coming back to for years, maybe longer. A hunting ground passed down like a family recipe, except the recipe was mammoth. Here's the honest limit of all this. No taphonomist, however careful, can climb inside a hunter's head from 15,000 years ago and know whether they saw themselves as feeding a village or slowly emptying a world. The bones can tell us what happened. They can't tell us what anyone understood about it at the time. Still, the field has landed somewhere close to consensus. Most researchers today, including the intellectual descendants of both Martin and Stewart, now treat this less as an either-or and more as a 1-2 punch. Human hunting pressure landing on populations already thinned out by a changing climate. Neither force alone quite enough to finish the job on its own. A mammoth herd, stressed by shrinking grassland and thinned out by even occasional hunting pressure, doesn't need a single dramatic event to disappear. It just needs enough bad years in a row with no room left to recover. Extinction rarely has one cause. It has a last straw. That combination also explains something that used to puzzle researchers: why megafauna on some continents held on for thousands of years after humans arrived, while others vanished almost immediately. Slower climate shifts in one region bought animals time. Faster ones removed their margin for error entirely, and hunting pressure that a healthy population might have shrugged off became the difference between surviving and not. Which brings the story back to New Zealand, because MOA give you numbers precise enough to feel the speed of it. Radiocarbon dating puts significant Polynesian settlement at roughly 1280 CE. By around 1400, every Maoe on the islands was gone. That's not a slow fade across centuries. Paleoecologist Richard Holdaway, who dated dozens of Maoe hunting sites, called it one of the fastest large-scale extinctions ever documented, potentially within a single human lifetime, 2 at most. A 12-foot bird, one that had no natural predator on the islands for millions of years, gone in less time than it takes a language to drift into a new dialect. Zoom out far enough, and the line between ancient humans and us gets blurry fast. We like to imagine early hunters as small, vulnerable, barely surviving against nature. The mammoth pits say otherwise. A few dozen people with sharpened wood and a good plan could reshape an entire continent's wildlife within a few thousand years. No factories, no firearms, no fossil fuels required. Which is the uncomfortable part to sit with. It's tempting to treat overhunting as a uniquely modern sin, something that only started once we had trawlers and bulldozers. It didn't. Barely more than a century ago, passenger pigeons filled North American skies in flocks so dense they blotted out the sun for hours, an estimated 3 to 5 billion birds. Unrestricted hunting alone brought that number to 0 by 1914. Different tools, same slow breeding versus hunting pressure math that emptied the mammoth steppe. The pattern of taking more than an ecosystem can replace never really went away. We just got faster at it. So picture that field outside Mexico City again. 2 quiet pits, grassed over now, that once swallowed 14 mammoths one at a time. Nobody who dug them thought they were ending anything. They were just solving dinner. And maybe that's the real unsettling part. Not that ancient hunters were uniquely reckless, but that they were exactly as short-sighted, resourceful, and human as we are right now, staring at a much bigger version of the same whole. If questions like this get under your skin the way they get under ours, stick around. There's a lot more buried in the fossil record than anyone expected, and we're not done digging.